We are going to see about theorem 2.5. So let A be the infinitesimal generator of C naught semigroup of t. Let the function f is belongs to L1 of 0 comma t is 2 of x. Let the function be continuous on the interval 0 comma t, and let v of t equal to 0 to t of t minus s f of s ds. So the initial value problem given here is it's a non-inhomogeneous equation. So du of t divided by dt equal to a into ut plus f of t greater than 0, u of 0 equal to x. It has a solution u on 0 comma t for every x belongs to a d of a if and only if the following conditions are satisfied, which means v of t is continuously differentiable, v of t belongs to d of a for 0 less than t less than t, and v of t is continuous. It is continuous on 0 comma t. So if one has a solution u on 0 comma t for some x belongs to d of a, the v satisfies all the conditions mentioned above. So let A be the infinitesimal generator of the C naught semigroup T of t, and we define a function f belongs to L1 of 0 comma t is to x be continuous on 0 comma t, and let v of t v of t 0 to t minus s f of s ds. So assume that the initial condition by here u dash of t equal to a into u of t plus f of t u of 0 equal to 0, and it has a solution is given by u of t equal to, and we know that by infinitesimal generator we know the form, that is u of t equal to t of t x plus 0 to t minus s f of s ds. Consequently we get v of t equal to u of t minus t of x. So v of t equal to u of t, this term, this considered as v of t means u of t minus t of t is differentiable for t greater than 0, and the difference of two such differentiable function is v dash of t equal to u dash of t d by dt t of t x. We know that this u dash of x d by dt u of x can be written as au. Here it is a of t of x. So v dash of t equal to u dash of t minus a of t. This is t of t ax. It is continuous on 0 comma t. So v is continuously differentiable. So v dash of t is continuous on 0 comma t. This implies v of t is continuously differentiable on 0 comma t, and also if x belongs to d of a, t of x belongs to d of a for t greater than or equal to 0. So v of t equal to u of t minus tx of t belongs to d of a for t greater than 0. Multiply a into v of t equal to a into u of t minus a into t of x, which means this is defined as ut of a of u of t can be written as a of u of t can be written as u dash of t minus f of t. So it is u dash of t minus f of t minus a t of t. It is continuous on 0 comma t, thus v of t belongs to, this is also continuous and it is belongs to d of a. So 0 less than t less than t, and a v of t is continuous on 0 comma t by the definition of v of t equal to u of t minus t of t. We know that u satisfies the variation of the constants, so is continuous, so it is satisfies the variation of the constants formula. So we assume that u of t equal to t of t x plus 0 to t of t minus s f of s ds. So we compute v of t equal to u of t minus t of ts. If we minus means this term t of tx can get cancelled and balance these terms. So assume that v of t plus x, so integral instead of t there will be t plus h, and subtract them with v of t plus h minus v of t. So 0 to t plus h, 0 to t, and what we do means split the interval 0 to t plus h as 0 to t plus h. So minus t 0 to t of t minus s. So take this interval as first, and combine this interval. So 0 to t of t minus h of s minus t of s f of s ds. By using the semigroup property, we know that multiply f of s means we get this can be splitted into t of h into t of t minus s minus t of minus s f of s ds. So if we take t minus s as common means t of h minus I f of s ds. So t minus h minus I 0 to t minus s f of s ds. So it is this one, and we assume that this as a v of t. So it is v of t. So v of t plus h minus v of t can be written as this form plus t to t plus h, t of h, t plus h minus s f of s. So uh, this can be, if we take this to this side, means like this, divide both side by h. If we divide both side by h means we get this term, and the second order term of LH is if limits tends to 0 means both terms, so it will be 0. By using the L hospital rule, we have to take the derivative. So 1 by h of t, t plus h, t of t plus h minus s, f of s ds, and if we t plus h, t plus h minus t plus s getting cancelled, and the left is f of t, f of the balance is here. Instead of s we have to substitute this. So f of t plus h, here h tends to 0 means we get only f of t. So from the continuity of the f, the second term has the limit of f of t, h tends to 0. The first term is derivative, and the left term gives and the left hand side of t, h of minus I divided by h, v of t. So if we take the limit means this one, so using the L hospital rule we have to take the derivative 1, here t dash of h, v of t. So this is generally written as a into v of t. So combine the limit of 1. What is the limit 1 here? Combining the limit of 1 means this one. So a into, here is v of t is v dash of t minus, like this we have to take a into v of t equal to v dash of t minus f of t. So we put v equal to 0 means v equal to 0 means u of t can be written as a into u of t can be written as t of t x